Guided exercise number 1 says evaluate the following definite integrals. And part A says evaluate the definite integral from 0 to 1 of 24x to the 23rd power over square root of 1 plus x to the 24th dx using the E6 technique with FTC2. So this is the thing that we're referring to as method 2. So when you use method 2, you should switch over to the indefinite integral. So the indefinite integral, and I'm going to go ahead and split this up a little bit. 1 over root 1 plus x to the 24th times 24, that's not a 24, 24x to the 23rd dx. And then your u should be 1 plus x to the 24th, and your du should be 24x to the 23rd dx. Notice that I wrote down an indefinite integral. In particular, notice that I did not write down limits of integration for this indefinite integral. And so what I have here is the indefinite integral of 1 over root u du. By the way, these are the things. We'll go ahead and match the color in the previous section. Here's my u, and here's my du. And so I make the substitution. So I'm doing the indefinite integral of u to the negative 1/2 du, which is 2u to the positive 1/2 plus c, which is 2 square root 1 plus x to the 24th, and then plus c. So that's the answer for the indefinite integral with the same integrand. And so now we need to go back to the original. So back to the definite integral. So do the definite integral from 0 to 1 of 24x to the 23rd over root 1 plus x to the 24th dx. So what we've already worked out is we've already found an antiderivative for our integrand. So according to the fundamental theorem of calculus, part 2, once we have that antiderivative, we can use it to do this definite integral. So 2 square root of 1 plus x to the 24th, evaluated at 1 and evaluated at 0, and subtract. So I get 2 root 2 minus 2 root 1. When I plug in 1, then plug in 0. So technically we haven't done anything new in part A because we've done these indefinite integrals. That's what we did in E6. And we've used the fundamental theorem of calculus part 2. We did that a couple of sections ago. And so all of this is method 2. Now, we're not going to talk a whole lot about method 3 because it's really more of a just like guess and see how it goes kind of situation. But I will go ahead and mark, if you just wrote this part down right here, if that was all you did on this problem, that would be method 3. So it's almost the same thing as method 2, it's just you're guessing instead of working out the u substitution explicitly. So that's using the old techniques to do this problem. Part B says evaluate the definite integral from 0 to 1 of 24x to the 23rd over square root of 1 plus x to the 24th dx using substitution with definite integrals, which is method 1. This is the new one. And so here's what you do. You'll notice that in this sort of helper box that I put underneath this part, that there's more stuff in it now. And it's because we need to make room to also account for the limits of integration that will change. So the u is the same as it was before, 1 plus x to the 24th. The du is 24x to the 23rd dx. Double check that you actually put that dx on your paper. I just noticed that I accidentally left one off here. It needs to be there. And then here's the different part. You need to keep track of what your inside function, so your u or your g of x or whatever, keep track of what your inside function does to your limits of integration. So AB in this example is 0, 1. So g of a is going to be what you get when you plug 0. So here's your a, here's your b. So g of a is going to be g of 0, which is what you get when you plug 0 into your inside function, which is 1. G of b is going to be what you get when you plug in 1 into your inside function, which is 2. And so this 1 is your new lower limit of integration, and the 2 is your new upper limit. So you use your old lower limit to get your new lower limit. You use your old upper limit to get your new upper limit. And now we're ready to do the substitution. So this time when we substitute, so I'll go ahead and rewrite the problem just so that we can keep track of it a little bit easier. 1 over root 1 plus x to the 24th times 24x to the 23rd dx. Okay, so let's see, purple u, red du. And then we need to remember to change the limits of integration. All right, so our new definite integral is going to go from 1 to 2. It's going to be 1 over square root of u du. And once we've done this, the x's are gone, completely gone. Don't even have to think about them ever again in this problem. It's like they were never there. X is gone. So let's go ahead and rewrite the definite integral in a more workable form. So 1 to 2 u to the negative 1/2 du. So that's going to be 2u to the positive 1/2, evaluated at 2 and at 1. So we get 2 root 2 minus 2 root 1, which is the same thing that we got in part A. In my opinion, this is a little bit cleaner because when you do the substitution and actually change your limits of integration, you completely get rid of x and you don't have to go back to it at some later point in the problem. A lot of people, students, professors, everybody, it's really easy to forget to go back to x if you use a u substitution as an indefinite integral and then go back to your original. And so to me, going ahead and changing your limits of integration is a better strategy because I think it's easier to make sure you get it right in the end. But you have options and you should choose the option that works best for you. You should also spend some time after watching this video to think about which one of these strategies you like better.